So let's talk through the answers to the questions that we've been through. Okay, so the first thing I want to take you through are the hormones and their function. So what I've done is I've just popped this table onto the slides, and you don't have to remember every single bit of it at this point, but it's a nice broad bit of information. So things that you could have said, you could have talked about the pituitary gland, which produces ADH, which is a hormone that limits the amount of urine being produced. We'll talk about that later on. FSH and LH, which are hormones involved in the menstrual cycle, and TSH, which is about growth in children. You could have said, and lots of you did, the thyroid gland is where thyroxine is made, and thyroxine is to do with growth and metabolism. So metabolism is all of the chemical reactions that happen in your body. The pancreas, which produces insulin and glucagon, which controls your blood sugar levels. That's what we're going to do today. You have the adrenal gland, which produces adrenaline. And quite rightly, lots of you said that it increases your heart rate, and it's that fight or flight mechanism. It's the hormone that makes you able to do more than you thought you would be able to do when you're in the face of danger. And lastly, we have ovaries that produce estrogen and testes that produce testosterone. So that's just a nice table there for you to have a little look at in your own time to remind yourself of just the names of some of the different hormones that we're going to look at. And the other two questions were really well answered that I could see in the Q&A and are actually quite simple, but they're really important to remember. So hormones are made in organs called glands, and there are lots of different glands. In the last webinar, which is available for you to rewatch, we looked at the position of some of these glands in the body. And question 2, how do hormones reach the target organ? Through the bloodstream. That's really, really important. Okay. Going through the bloodstream to get from the gland to the target organ where it's going to make something happen. Somebody's just asked, what does ADH do? It's a hormone that reduces the amount of urine you produce so that you don't lose a lot of water. It's to keep water balanced in your body. But we'll look at that in a later webinar. So let's look at what we're going to do today. We're going to talk about the control of blood glucose. So we're going to recall the hormones involved in regulating blood glucose, and we're going to talk about what diabetes is. And lots of you will have ideas about diabetes. Many of you will know somebody affected by diabetes, and you may remember studying this in lesson as well. So we're going to build upon what we've already done and what we already know. We're then going to compare how the body responds to a low blood glucose level to a high blood glucose level. How does the body correct the levels and bring us back to a nice balance? And that's homeostasis, if we remember, bringing us back to this optimum level. We're also going to talk about the differences between type 2 and type 1 diabetes and look at the treatments for diabetes. Now, before we go into how the body controls blood glucose, let's think about what I mean by blood glucose itself. So glucose is a scientific name for a type of sugar. And these sugars you will eat as they are when you eat foods that are sweet or high in sugar. And you'll also take on glucose when you eat carbohydrates, because carbohydrates are long chains of sugars that are bonded together. So when you eat things like bread and potatoes and porridge, we say that they're like a slow release because they've got lots and lots of sugars that are then broken down slowly over time to be released. Now that glucose is really important in your body, and we primarily use it for a process called respiration. And respiration, as you should know, is the process that your cells will undergo to release energy so that your body can do a variety of different things that keep you alive. The body stores some of this glucose, and it's really important that it does, because we don't eat 24/7, but we do need to do respiration all of the time. Okay, I know it might feel like in lockdown we're eating 24/7, but we're genuinely not. And we need to have stores of glucose in our body that we can access when we need it. So for example, when you get up in the morning, you haven't eaten all night because you've been asleep, and you still need the energy to get up, to walk downstairs or walk along to the kitchen, to have a shower, to do all of those things. And that's where your body will get that energy from. It will go into the stores of glucose that it has and use that for respiration. And it's really normal to have glucose in your blood. So on this top picture here, you can see just some really simple images to show what we mean by low blood sugar, normal blood sugar, and high blood sugar. We're talking about how much glucose there is in comparison to the other parts of your blood. And a normal level will be in balance. At the bottom here, I have included a little table, and you don't need to know any of these numbers, but I wanted to show this table because you'll see that it says before the meal and after a meal. And you can see that the levels of blood glucose are different. And so when we go through how the body balances blood glucose, we have to remember that it's really normal for our blood glucose level to be different at different points in the day. When we've just eaten, our blood glucose is going to be higher. And the insulin in our body needs to work to bring that down to a nice normal level. When we haven't eaten in a while, we feel lethargic. We feel a bit ratty sometimes. I know I am. And that's to do with having low blood sugar. And the body needs to break down some of the stores that you've got, or you need to eat. So blood glucose, really important that we have a nice balance. But how do we maintain that balance? The image I'm going to show you on the next slide is called a negative feedback loop. And a negative feedback loop is how the body counteracts any change to that balance. So we could be talking about anything here. We could be talking about your body temperature or the amount of water. But a negative feedback loop will monitor how much of the thing you've got in your body, for this case, blood glucose. It will look at if it changes. So does it go higher or lower? And it will bring it back to that nice balance by doing a couple of different processes. Now, the image I'm going to show you now, let me just move myself out of the way. This is a negative feedback loop for the maintaining of a normal blood glucose level. I know you're going to look at this and go, what? It's a little bit complicated. But I promise you, if you can really read through this diagram that we're going to do together in a second, and if you can commit this to as much of it as to memory as possible, so maybe doing a little diagram of it and sticking it on your wall, this is going to help you answer pretty much every single question that we have set for you for the rest of the week. It's that important. So let's talk through it and then think about some scenarios, okay? So in the middle here of this diagram, we have got what we call homeostasis. And homeostasis is balance. So this is what we would call your normal blood glucose level. And here they've given you a number. It's around 90 milligrams per 100 mil, but you don't need to know that off by heart. So let's think about what happens if the blood sugar level goes up. So we've just eaten a meal. I've just had a really sugary cup of coffee. It's nearly Easter. I might have had a cream egg. Blood glucose is going very high if that's the case. And that's the stimulus in my body. So my pancreas, which is an organ that both detects blood sugar and then releases some hormones, is going to detect that my blood glucose level has gone up. And when my blood glucose level goes up, the pancreas releases insulin. And specifically, the beta cells in the pancreas release insulin. Insulin is a hormone. So the pancreas has released insulin, and that insulin is going to try and bring my blood glucose level back down to normal. And it's going to do that in two ways. The first way is it's going to encourage and stimulate my normal body cells to take up more glucose. So it's going to bind to those cells and say, right, come on, absorb some more glucose, do some more respiration, which is why you often get a little burst of energy after you've eaten. The other thing insulin does is it stores the excess glucose as a substance called glycogen. And these little glycogen molecules are nicely packed in your liver until you need to use that for energy when you have lower blood sugar level. And we'll talk about that in a second. Once you've done those two things, then your blood glucose level comes down because some of it's being used by your cells and some of it's being nicely stored in your liver as glycogen. Because those two things have happened, you would then come back to homeostasis. So let's talk through that cycle again before we look at what happens if your blood sugar levels dip. So you've eaten something really sugary, in my case, a cream egg, but don't remember the cream egg bit necessarily. You might have other things that you eat, obviously. So stimulus, my blood glucose level, my blood sugar level has increased. My pancreas detects this and releases insulin, which is a hormone. That insulin tells my cells to absorb more glucose, and it also tells my liver to store some of the excess glucose as glycogen. Because my body's done those two things, my blood glucose level comes back to a nice normal level. Now, that little cycle there happens in the body of somebody who has a normal insulin response. So the everyday person, we're not talking about somebody here with diabetes because they will do things slightly differently. I'll go through all of this again in a second, but let's go through homeostasis if your blood glucose level drops.
Miss, can I just make the point here that when our blood glucose level drops and we talk about those hormones, in the specification, this is for the higher tier only students. So the bit that you've just talked about is for everybody. But the bit that you're now just going to be talking about will be those people who have an ambition to sit the higher tier paper.
Thank you, Ms. Bush. Yeah, absolutely. And it's just the opposite way around, but it involves another hormone, and you can get a bit confused with the wording, I think is why it's probably higher tier only. So let's look at what happens when blood glucose level falls. So maybe I haven't eaten in a while. Okay, maybe I've expelled lots of energy in a day and I'm having a bit of a crash later on. So my pancreas, again, is going to detect that the blood glucose level has gone down. I don't have as much as 90 anymore. I've got something below that. And this time, not my beta cells, but my alpha cells release a hormone called glucagon. And I appreciate that sounds very similar to glucose and glycogen, but bear with us. My pancreas is going to release glucagon, and glucagon is going to go to the liver and is going to make the liver break down the glycogen into glucose again. So remember, when you had too much glucose in the blood, the insulin told it to store, the liver to store the glucose as glycogen, okay, which is these stacks of, well, not stacks, but that's how the glucose is stored long term. Glucagon comes along and causes the release of the glucose from that glycogen. And that means that as your glycogen is being broken down, you're going to have more glucose in your blood. And that's going to bring you up to this normal 90 milligram per 100 ml level. And that is what we call homeostasis. Now, some of you are saying, do you have to take notes? No, not at this point. I talk quite quickly. But you are going to have to do some sort of B2 assessment at some point. And this in itself is revision. So if you wanted to, when you're watching the webinar back to assist you with the work you need to do, it might be an idea to get this diagram down particularly. This is a very important diagram because it simplifies things. So let me quickly summarize this for you. When your blood glucose level goes up, when you've got high blood sugar levels, your pancreas is going to release insulin. It means you absorb more glucose and you store more glucose as glycogen. That will bring down your blood glucose level. So insulin brings down your blood glucose level. Those of you on the higher paper who want to do the higher paper, if your blood glucose level falls, so you don't have as much blood sugar as you would normally do, it's glucagon that is released from the pancreas. And glucagon increases your glucose levels by breaking down glycogen. So this process happens in everyone. Everyone will produce insulin to store some of that glucose, because when you eat and you've got loads of sugar in your food or carbohydrates, you don't need it all right away. So your body needs to have a way of storing it and making your cells absorb it. And that's what insulin does. It's really, really, really important. And what we're going to talk about in a second is what happens when your body doesn't produce insulin in the right way, or your cells don't respond to insulin in the right way. And that's called diabetes. Now, I know some of you are feeling a little bit wobbly with this still. Can I ask at the end, once we've finished the webinar, I will stay and answer specific questions about this when we've got a point where people can go if they're okay with it, and I'll answer some specific questions. If not, you will just have to go over this again, okay? It is a diagram. Those parts on the diagram that we've gone through, they are really important. If you can remember them, that's you answering basically every question on control of blood glucose, okay? So it is a really important one. Now, what I wanted to show you here is in the corner, there is another video that I have linked called Negative Feedback Loops. And this is another excellent video from Miss Yarvi. And it's for those of you who are looking, again, like Miss said, with the ambition to do the higher paper. And she's going to take you through what a negative feedback loop actually is. This is one example, but she's going to go through some other examples to help you understand that. And that should be linked on your Google Classroom along with all of the other slides. So, as I briefly mentioned, if your body doesn't do that process properly, for whatever reason, we talk about the idea that a person might be diabetic. And there are two types of diabetes that we're going to look at. We're going to look at type 1 diabetes and type 2 diabetes. And you are likely going to know something about either type 1 or type 2. And you might just know it as a fact about diabetes. But what we need to really specifically go through is what causes each one, what each one really means. So what does it actually mean if somebody is type 1 diabetic, and how we treat each one. Now, before we go on, there is another type of diabetes you may have heard of, and that is gestational diabetes. And that is diabetes that a woman may get when they're pregnant. And that is due to a number of reasons, but it's a lot to do with the hormone levels being slightly different during pregnancy. That is not something you're specifically examined on, but it is good to be aware of it. On the screen are some really, I think, important and interesting facts about diabetes and just how prevalent it is. Diabetes, particularly type 2 diabetes, is on the rise. And it's something that as a country and as an NHS, we're having to deal with more and more as lifestyles change and perhaps in some cases get slightly worse. And that can lead to people suffering from type 2 diabetes more, but also for their diabetes to be more serious. So on the board, you can, on the screen, I should say, you can see 3 images. I'm going to talk you through these, but I do have it summarized in a table in the next couple of slides. So this is a pancreas. I know it looks a bit funny, but I promise it's a pancreas. And a healthy pancreas releases insulin, which binds to a cell and tells the cells to absorb glucose. You can see that here because the glucose is going into the cell. There's less glucose just left over, and some of that glucose will also be stored as glycogen. In type 1 diabetes, the pancreas does not produce enough insulin. It doesn't produce enough insulin, which means that the glucose isn't being stored as glycogen and it isn't being absorbed into cells. Now, if you know somebody who's type 1 diabetic, sometimes they can feel really tired and they can struggle after meals. And that's because their body isn't responding in the way it expects to. The cells aren't absorbing enough glucose for them to do respiration, and it's not storing enough glucose to use at a later date. And that's why people who are type 1 diabetic need to inject insulin because their body doesn't produce it themselves. And so that insulin will then help their cells take up the glucose it needs and store some of it for later on. Type 2 diabetes isn't where the body doesn't produce insulin. It's where your cells aren't sensitive to insulin anymore. They don't respond properly to insulin. And that means that your body isn't, again, absorbing the glucose it needs and storing the glucose it needs. Now, type 2 diabetes can be treated with an insulin injection, but often type 2 diabetes can be the result of poor diet and poor lifestyle. Think about if you're ingesting large amounts of glucose, then your cells can become less sensitive to the effects of insulin because your body needs to produce a lot of it to keep up with all the glucose. Another image to show this is if we look at a normal pancreas here, this pancreas is producing insulin, and the insulin is going to help the glucose be absorbed by your cells. That's nice and normal. That's the process you want. In somebody with diabetes, the insulin isn't being produced at the same level. So less of that sugar is getting into the cells. This is everyone, the stuff I'm going over at the moment. This is the pancreas here. These green bits are supposed to be insulin. These blue bits are supposed to be glucose, and these are a collection of cells at the bottom. So those are some diagrams to illustrate what I mean, but let's look at it in a nice simple table. So type 1 diabetes is where the pancreas does not make enough insulin. Remember from what we looked at earlier, insulin causes your blood sugar to go down. It stores some of that glucose away and it makes your cells absorb more. Type 1 is thought to be genetically inherited. And normally, if you've got type 1 diabetes, you realize it quite early on in your childhood. Now, you can improve your symptoms in type 1 diabetes by having a healthy diet, which is lower in carbohydrates, and by exercising. But you often have to make sure that you're injecting with insulin or taking some additional insulin medicine. Type 2 diabetes is where your body cells don't respond to insulin like they should do. So when insulin is detected by your cells, your cells aren't absorbing any extra glucose like they should do. This means that your blood sugar is going to remain high. Now, type 2 diabetes is mainly linked with obesity, diet, and a lack of exercise, but there is thought to be a genetic component. So, for example, in my family, my dad had type 2 diabetes, my aunt has type 2 diabetes, and my grandfather does. I don't. I get regularly tested because there is a family history. But because it's type 2 diabetes, I can prevent myself from suffering, hopefully, with a balanced diet, with exercise, and making sure that I live as healthy as possible. Please ignore my cream egg comment from earlier. That is not obviously a good example of me living healthily. Most people with type 2 diabetes don't realize until later in life, and actually don't suffer with it until later in life. And that's genuinely the differences between the two. They both involve an inability of the body to regulate, to balance the blood sugar. Now, how do we treat it? Well, type 1 diabetics and some type 2 diabetics will inject with insulin, and that insulin will cause their cells to absorb more glucose and will cause more of that glucose to be stored as glycogen. Now, mainly type 2, we can just change our lifestyle and we will see our symptoms improve. Type 1 diabetes, you can also treat by carefully controlling the amount of carbohydrates you eat. Now, remember at the very beginning, when we talked about what blood glucose actually is, we talked about the idea that when you eat carbohydrates, your body breaks down those carbohydrates into sugars. Okay, so the less carbohydrates you eat, the less blood sugar you are going to have, and therefore your body will be able to monitor it more carefully. In type 2 diabetes, if you went to the doctor and you asked the doctor how to keep your diabetes under control, they would ask you to eat a balanced diet, where you didn't overeat carbohydrates, because lots of us do eat far more carbohydrates than we should do. Okay, it's a very common thing in people's diets. If you were overweight or obese, you may be asked to lose some weight. You would be asked to do regular exercise and possibly use some drugs that will increase your uptake of insulin by your cells and the uptake of glucose by your cells. As a last resort, if your type 2 diabetes is out of control, you may be encouraged to get insulin injections, but that really is a last resort with type 2, and you should be able to manage type 2 diabetes using a combination of other lifestyle factors. Now, in the future, there are some really exciting treatments for diabetes on the horizon, and one of them is using stem cells. Now, stem cells are unspecialized cells that can turn into any other type of cell if they're done in the right conditions. And we hope that in the future, for type 1 diabetics particularly, we could turn stem cells into beta cells. Remember, those are the cells that produce insulin. And if we could successfully make the stem cells into beta cells, which produce insulin, and put them in the pancreas of a person with diabetes, they may be able to produce their own insulin, which would be brilliant, because then they wouldn't need to inject all the time. Another possible treatment of somebody with insulin, with diabetes, is a pancreas transplant. Now, that's quite a big deal, and that would really be a last resort. And there are issues with transplants. First issue, it can take a very long time to get a transplant through the transplant list. Remember, almost all organs, with the exception of like a kidney, you have to get that organ donated from somebody who has died. And so it takes time for people on the waiting list to get to the top of that waiting list. Also, when you get a transplant from another person, there's always a risk that your body's going to reject it. There's always a risk that your body's going to not agree with it, is a really loose way of saying it, but reject it, which means that it doesn't work. And actually your own immune system starts fighting against this new organ, which is obviously very dangerous in itself. Now, type 1 diabetes is the way that what we would treat with a pancreas transplant, because remember, in type 2 diabetes, it's not that you're not making insulin, it's that the body isn't responding to that insulin well enough. So I'd have to look it up in a bit more detail, but to my knowledge and from my understanding, a pancreas transplant would only really work with type 1 diabetes. So I know this is very, very quick, and I'm sure that lots of you have other questions. Before I show you the work I'd like you to complete this week, I'm just going to quickly go back to the diagram that I showed you that I think confused a lot of people. This is something you're going to have to come back and study. If you don't get it, you need to understand what happens when the blood glucose level goes up. So what happens when there's too much blood sugar? How does your body correct it? And that's what the entire top half of this diagram is showing you. It's showing you how you can correct when the blood sugar is too high. And that's by producing insulin, which makes these two things happen, which brings down your blood glucose. Diabetes is when that process doesn't happen properly for two reasons. And there are two separate types of diabetes. There are different ways to treat each of those types of diabetes, as well as some really exciting future treatments for diabetes. These are happening at the moment, but we're still in an earlier stage of those treatments, and we're still looking at it more and more all the time. Now, on this slide here, and these slides will and should be shared in your Google Classrooms by your science teachers, so all of this is available for you to go back to. You can see there are three little links here that are going to help you. So the first link is just about that balance, how the body naturally balances blood sugar level. The second link is a bit more about the difference between type 1 and type 2 diabetes and what it means. And lastly is a video about, very similarly to what I've gone through with you, but if you wanted it explained in a slightly different way. These are here to support you if you're struggling still. If you've watched this webinar back when it's been uploaded, still not quite sure, and you want to support your revision and your answers a bit more. In terms of what you need to do this week, your next timetabled science session is Thursday, and you will need to rewatch this webinar, which will be linked to you via Google Classroom by your teachers. You may also want to watch the video on negative feedback loops from Miss Yarvi, and if you are, like Mrs. said, talked about having the ambition to take the higher paper, you're going to want to watch that video because it is very important. And you'll need to complete the quiz. Okay, the quiz is about 19 or 20 questions long. It's not massive and will really help you understand what we've done today. On Friday, you've got your second timetabled science session, which is where I would like you to use all of these resources to complete some slightly longer exam questions that I'm going to show you in a second. If you manage to do all of that and you're feeling really confident and you are really interested and you have some extra time, I'd like you to have a little look through these links down here about how we can use stem cells in future treatments for diabetes. It's really fascinating. And like I said, there's no expectation for you to do that. But if you are looking at those top grades, it is something that would be really good for you to read into so you have a deeper knowledge of it. Now, let's look at the longer answer questions that you have been set. So it's very similar to what we set you last week. I've put the links to the resources to help you if you need additional resources. And the first two questions that you have on here have mark schemes directly below them so that you can mark your answers. After that, there is a section for you to answer a few more questions. And these aren't particularly long questions. The top amount of marks for each of these is 4, okay? So it's not huge amounts of 6 markers. Some of them are tough, particularly as question 7 is tough because it links knowledge from B1, which was quite a while ago. If we go back to the very first question on here, I've given you a really standard question that hopefully will help you see how all of this is linked together. So it says, explain how the 2 hormones, insulin and glucagon, keep the blood glucose concentration at the correct level in the human body. Now, the first thing you will do is you will go back to the slides or to the webinar and you'll find that diagram. You'll have it next to you. You may have it on a slightly different tab. All you need to do is talk through it. What happens when it goes up? What hormone is released? What effect does that have? That then brings it back to a balance. What happens when the blood glucose level drops, etc., etc. When you've done that, you're going to then scroll down to the mark scheme and give yourself a mark out of 5. If you didn't get full marks, think about how you can improve that answer and make some improvements to get your full 5. That is a nice question. There are only so many ways they can ask you about blood glucose concentration and how it's changed in the body. So that's a really clear one. The second question includes a graph, because most of the questions that you can find about blood glucose concentration, they do tend to include some sort of graph that you just need to read the information from. Most of the information is all here for you. It's a 3-mark question to interpret the graph and the information they've given you. Have a go, make 3 points, and then mark your answer. When you've done those 2 things, you then want to have a go at these questions, which are very similar to the ones that you've already answered in the examples above. So that's the work that you need to do this week. Now, what I'm going to do now is I'm going to say that anybody who feels confident and who understands what we've been through, more than happy for you guys to leave and to have a little look at your quiz, etc. Thank you for coming. Anyone who's got any additional questions, I'm happy for you to either ask in the Q&A or you can pop your hand up and I will unmute you and you can ask the question to myself and Mrs. Bush and we can help you a bit more because I don't want anyone to leave here completely confused, okay? But if you are leaving now, thank you so much for coming. I'm going to put this all up on, this is all up, I should say, on Google Classroom. And as soon as we're finished here, this link will be downloaded and put on YouTube as well. So I'm going to answer one question quickly before I go through the homeostasis thing again, as somebody's asked. The B2 assessment, will it include evolution as well as homeostasis? It will do, yeah. And we are going to get through B2. We're not going to spend all our time on the earlier parts of B2. We are going to move on to the other sections that come up right at the end, because it does sort of change, doesn't it, B2? But we will come back to it in a later webinar. So quite a few people want me to go through the other things again. So I'm just going to do that. First of all, remember, you can leave now if you understand this. Somebody's asked me what these things are on this diagram. So this is just a cell. It's a really simple diagram of an animal cell. And that brown thing in the middle is the nucleus. Okay. And this is just showing you how insulin attaches itself to the cell and causes it to absorb more glucose. Okay. So some people really don't get it, all right? And let me just be really simple now and try my best to make it clear for you. So when you eat, your body is going to break down your food in your stomach, and then you're going to absorb what you need through your intestines, okay? I'm answering it live. Oh, Miss, is that what you, oh, sorry, I'm getting confused by something that said on there. So your body is going to break down your carbohydrates and your other substances in your food into useful little bits that you need. And one of the things that you need is glucose. And glucose is what you use for respiration. It's what gives you energy. So it's really important that you've always got a balance of it in your blood. And this diagram shows you what to do and what your body's going to do when it's not in balance. So in this first bit here, I've eaten a meal that has lots of sugar in it, or it doesn't even have to have lots of sugar in it. I've eaten a meal and my blood glucose level is just going to rise. And that's natural. That's normal. Of course, it's going to go up. I've just had some food. But the body doesn't want loads of blood sugar flowing around in your blood, because if it didn't store it, it would eventually just, that level would just go down and you'd be left without any backup stores. So instead, your pancreas, which is this funny looking organ here, it detects that you've got an increased level of blood glucose, and it releases insulin. That insulin causes your body to absorb more glucose and to store more glucose. That means your blood sugar goes down. Now, really simply, if your blood sugar goes up, you release insulin, and that will eventually make your blood sugar decrease. The reason for that is that you're going to store more of it as a substance called glycogen, and your body is going to absorb more glucose. I think that should answer your question. Anybody remaining has any specific things? Someone said just a minute ago, where are these cells located? All over your body. Every cell in your body needs some sort of glucose to respire, okay, with the exception of perhaps your blood cells that don't have a nucleus. Even then, actually, they'll need glucose to respire. So these are all around the body, okay? Okay, so the person that says it makes no sense, if you want, do you have anything specific that you want me to explain? If not, you can pop me an email. I'll be around and I'm happy to explain it in more detail for you then. If not, email your specific teachers and see if they can give you any support. It's difficult because I can't see you and I can't write things down for you really clearly. But that would be my advice to you. Okay, so the fundamental here is that we're just talking about how we can get a nice balance of blood glucose. If you can go away and remember that when you have too much glucose in your blood, normally after you've eaten a meal, your body makes insulin, then that is a really good start, okay? So if you can remember that insulin is what your body produces when your blood sugar level is high, that is a really fantastic start that you can then build on, okay? So if you still don't get it, go away and write that sentence down. So when your body releases, when your body has too much blood sugar, you're going to release more insulin, which is going to bring that overall level down, okay? Do I have any new questions, any other questions before I shut us down so that the next teacher can come on and do their Zoom? Okay, thanks very much, everybody. I'm going to end the meeting now, and this will be available on your Google Classroom once it's been downloaded and uploaded to YouTube. Thanks very much, Mrs. Bush, as well, for helping, and have a good day, everyone.